everyone, welcome to my channel. My name's Riley Taylor and today I'm going to be showing you how to take sets and put them into Venn diagrams. So this is the problem we'll be solving. The instructions say, fill in the Venn diagram with the appropriate numbers based on the following information. So if we read through, it says A contains 26, B contains 32, C contains 23, the intersection of A and B contains 10, the intersection of B and C contains 12, the intersection of A and C contains 8, the intersection of A, B, and C contains 3, and the universal set contains 65. Before we start solving the problem, let's first go over some simple definitions and terms. Looking at the Venn diagram, you can see there's 3 circles, each labeled A, B, and C. If we were to break it down, the circle that's labeled A is set A and can be written like this. The circle labeled B is set B and can also be written like this. And the circle labeled C is set C and can be written as well like the other 3, like that. So basically a set is a collection of elements or members, whether it be numbers, letters, or words. Looking at the Venn diagram, you may have noticed that it's bordered by a box that's labeled with a U. This U is indicative of the universal set. And the universal set is a set of all sets and contains all the elements of every set. So anything contained within the box of the Venn diagram is a part of the universal set. Looking at our original problem, anything within the set A, B, C, all of them, or anything within this box is a part of the universal set. So let's begin solving the original problem. The easiest place to start is where all 3 sets intersect. So this would be in this middle portion right here. So as written on the original problem, the intersection of A, B, and C is 3. So for this middle portion where all 3 sets intersect, we're going to write 3. The next best place to start is where the 2 sets intersect together. So if we were to look back at the original problem, the intersection of A and B is 10. So the intersection of A and B would be right here. And since we already have 3 there, we know that this portion right here must be 10 minus 3. 10 minus 3 is 7. So this portion right here would be 7. Next, if we were to look at the intersection of A and C, we know that this is 8. This would be right here. And because we already have 3 there, we know that this must be 8 minus 3, which is 5. So this portion right here would be 5. Lastly, the intersection of B and C, which is right here, has a 3 in it, so we know that this must be 12 minus 3, which is 9. So this little portion right here would be 9. So now we have all the places that the sets intersect filled in. Lastly, we're going to fill in the rest of the set that hasn't been filled in yet. So as given by the original problem, the set A contains 26 elements. Set A would be this entire circle right here. Since we have 5, 3, and 7 in that set, we know that we need to add those together and subtract from the number given. So 5 plus 3 plus 7 is 15. So we need to subtract 26 minus 15, which would be 11. So we know that 11 must go in that portion. Next, set B would be this entire circle. Since we have 9, 3, and 7, we have to add those together and subtract from 32. So 9, 3, and 7 added together would be 19. So 32 minus 19 would be 13. So 13 goes right here. Lastly, set C. Since 9, 3, and 5 are contained within set C, we know that we must add those together and subtract from 23. So 9, 3, and 5 added together is 17, and 23 minus 17 is 6. So 6 goes right here. If you wanted to check and make sure that these answers were correct, you could add all numbers in each set and they should add up to the number given. So for example, set A, all these numbers within this set should add up to 26, all the numbers in set B should add up to 32, and all the numbers in set C should add up to 23. Lastly, we're going to move on to check that our universal set contains 65 elements. So to do that, we would have to add up all these numbers and see what the outcome would be. So we would add 11 plus 7 plus 3 plus 5 plus 9 plus 6 and plus 13. If you were to add all these together, this would equal 54, which does not add up to our universal set of 65. 65 minus 54 is 11. So we know that we are missing 11 elements somewhere. They are not contained in the set, but we have 11 left, so we know that we must put 11 outside of this box right here. So to recap, set A contains 11, set B contains 13, set C contains 6, the intersection of set A and B contains 7, the intersection of set A and C contains 5, and the intersection of set B and C contains 9. Lastly, the intersection of set A, B, and C is 3. And since this only adds up to 54, we know we're missing 11. So we write that outside in the box. So that is all for the problem. If you wanted to check your answers and make sure, you could add all the numbers up within this box and they should add to 65. Thank you for watching and I'll see you next time. Bye!